Suppose we have a coin that is rigged. So when we toss it, the probability of heads result is 0.65. The first question is, well, if that's so, what is the probability of getting a tail? Well, there are only two outcomes when we toss a coin, so the two probabilities must add up to 1. So we just subtract 0.65 from 1 and get the other probability, which is 0.35. All right. So now the next question is, we toss this rigged coin 4 times. What is the expected value of the number of heads? Now, if we toss a coin 4 times, and each toss can have 2 results, then the total number of outcomes is 2 to the 4th power, that's 16. That's not that large, so we can actually list this. Okay, so let's start with the probability of all 4 tosses being heads. Well, the first toss has a probability of 0.65 to be heads, and so do the others, because this is no replacement, because the coin never remembers, right? So this probability is 0.65 to the 4th power, which is 0.1785. Okay, next up, there are 4 different ways we can have 3 heads and 1 tail. If you look at the first one, the first chain, THH, the probability of that one, well, the first was to be tail, that's a 0.35 probability, and all the other 3 will have 0.65 as its probability. So we have 0.35 times 0.65 cubed. Now this other chain that says HTHH, the probability here is going to be 0.65 times 0.35 times 0.65 times 0.65. So it's just a rearrangement of this product, which means that the probability of getting 3 heads and 1 tail is going to be this probability times 4, because each of these chains have the same probability. So this was the probability of getting 4 heads. So now we're computing the probability of 3 heads. And so we get 0.65 to the 3rd power times 0.35 times 4, 0.384475. In the previous case, we rounded to 4 digits. So let's just keep doing that. So it's 0.3845. Okay, so now how can we get 2 heads and 2 tails? There are 6 different ways we can get 2 heads and 2 tails. This notation, 1, 2 represents the 1st and the 2nd spot where we get tails. 1, 3 is the 1st and the 3rd, 1st and the 4th place, and so on. So these are 2-element subsets in a 4-element set. At this point, it's probably no surprise that it's 4 choose 2. We choose 2 spots out of the 4 to have tails, and then the other 2 must be heads. So that's 6. 6 chains will have the same probability because the results are the same, it's just they are rearranged differently. The tails will each have a probability of 0.35, and the heads each will have a probability of 0.65. And so the probability of getting 2 heads is going to be this product. So we get 0.3105. If there were 4 ways to get 3 heads and 1 tail, there are going to be also 4 ways to get 3 tails and 1 head, right? The heads can be at the 1st, 2nd, 3rd, or the 4th place. So it's 4 choose 1. There are 4 such chains. The probability of heads is 0.65, and the probability of tails is 0.35, but that has to happen 3 times. So we get 0.1115. And finally, we could have 4 tails. That should be the least likely event because there is just 1 such chain, and the probability of tails is less than the probability of heads. It should be 0.35 to the 4th power. So that's 0.015. Okay, so let's just collect our results. Now, because we listed all possible outcomes, this probability should add up to 1. Maybe we'll get a slightly different answer because of the rounding, but it should be very, very close to 1. So it's a good way of checking whether we're in the right track if we just add this. So these probabilities, even though we round it, add up to exactly 1. That's very encouraging. So now for the expected value, we have all the probabilities, and the expected value is the sum where we multiply the event by the probability. To end up with 4 heads, the probability of that is 0.1785. To end up with 3 heads, the probability is 0.3845. To end up with 2 heads, the probability is 0.3105. To end up with 1 head, the probability is 0.1115. And actually, this probability is going to be multiplied by 0. So actually, we didn't really need to know that it's 0.015. All right. And that should be 2.6. So the expected value of the number of heads is 2.6. Granted, that will never happen, right? The number of heads is always going to be an integer, 0, 1, 2, 3, or 4. But if we play this game many, many times, the more game we play, the closer the average value of the number of heads will be 2.6. Thank you for watching.